Hi everyone, grade 12 learners. Today we are busy with work, energy, and power. Day 12. So as you know, every lesson we are answering one multiple choice question and one long question. Please take your time to try. So work, energy, and power, question 1. So you have box and then two forces acting, apply force and friction force, asking you the total work done on the box. So this is our question 1, multiple choice question, coming with 2 marks. All right, please try, please take your time to try. I will just carry on without wasting time, but you can stop video and then you can try. So this question, we are looking for total work done. We should calculate work done by applied force and work done by friction force, and differences will give you total work done. Our answer is D. Why and how we are getting D? Let's explain. Let's use our formula and let's calculate work done by these two forces. Work total equals work done by applied force plus work done by friction force. I will use two options for this question. First option is coming now. So first of all, what we have, what formula we are using to calculate work done by applied force? Force times delta x times cos. We are using cos different angles for. We are using cos 0. Why cos 0? Because we know they said direction of motion this way and object is moving delta x meters. So to the right. How we know to the right? Because they said friction force opposite direction of motion. Friction force always opposite direction of motion. Friction force is giving you direction of motion because opposite to direction of motion. So direction of motion and apply force, as you see, both of them to the right. And distance, just angle between these two, let's write F, and direction of motion, angle is 0. Plus friction force, now we are calculating work done by friction force times delta x times cos 180 degrees. Why we are using 180? Because this is direction of motion and this is your friction force, opposite direction. So as you see, angle is 180 degrees. And when you calculate this, F times delta x, and we know cos 0 is plus 1, and plus friction force times delta x times cos 180 is equal to minus 1. And you can write F times delta x minus F times delta x. I'm just using this minus 1 with plus 1 and then minus. And you can just take F minus friction force times delta x. As you see, our answer is D. This is our option 1 using work formula. And I'm going to use second option, calculating net force first, and net force times by delta x, also giving you answer. Let's use our second option now. We are going to calculate F net first. Net force is equal to F minus F friction. So, and then work net or total work we can write F net times delta x times cos 0 we can write. And F net is equal to F minus friction force times delta x. We know cos 0 is equal to plus 1. Just remove that. And answer is F minus F times delta x. We can remove plus 1, it's fine. Answer is D. This is our second option. Which one is easy for you? You can use that one. All right, let's continue with question 2. Now long question is coming. Question 2, we separate also 2.1, 2.2, just different slides. So let's see what they ask now. The diagram shows, okay, 50 kg object sliding down. Okay, direction of motion going down. That's the important point. Sliding down. That's tips. All right. And then angle is 30 degrees. Motion create this moves down, okay, control by work. Okay, controlling by work is the apply force is going up, but we know direction of motion down. Please don't forget that point. Okay, and then parallel, okay, just 300 tension force. We have this tension force is equal to 300 newtons, all right. Friction force 50, but what about direction of friction force? Also this way, remember that. Friction force this way, because friction force always direction of opposite direction of motion, always opposite direction of motion. Object is going this way, they said just sliding down, we just get direction of motion, and then we withdraw friction and then apply force. Okay, so we know this is 300, this is 50 newtons. For now, just we are taking from question and then writing down on the diagram whatever we know. So first question, 2.1. Draw a labeled free body diagram showing the forces parallel. So, okay, we are going to draw a free body diagram. How we are going to draw a free body diagram? First of all, we must just, okay, friction force, just double check what they said. Friction force, create a sliding down. So, okay. So what forces we have acting on this object? Apply force 300, friction force 50 newtons, and we have gravitational force. It is just down, so don't draw with angle. It is going down. So from here, just let's draw. This is our gravitational force, but we have what they said, free body diagram showing parallel one. So we busy only this one, not up and down, or not perpendicular one, parallel one. On parallel, what force we have? Fg parallel. So we have 1, 2, 3 forces for parallel. But if they ask you same question for perpendicular, we have Fg perpendicular and normal force. We are going to draw these two. But if they ask you full, full free body diagram, we should add these two also. But now they ask only parallel one. Let's see. Let's clear all and let's go to next slide to see our diagram. Yes, we have tension force, friction force, and Fg parallel. So for parallel one like this, but if they ask you full free body diagram, you are gonna draw another one here. What is that? Fg perpendicular, other one, normal force perpendicular. But one more time, if they ask full. If they ask you only perpendicular, you are going to draw only those two, normal force and Fg perpendicular. But for now, parallel one only, friction force, tension force, and Fg parallel. Done. Question 2.1 with 3 marks because we have 3 forces. Let's continue with next question, 2.2. They ask you the work energy theorem. Okay, work energy theorem is the net work done on an object is equal to change in kinetic energy of the object, or work done by a net force is equal to the change in kinetic energy. Object's kinetic energy on an object, you can just add. So what is that? Work done, work net equals delta EK. This is our formula for work energy theorem. All right, this question 2.2 coming with 2 marks and definitions coming always. Yes. Next question 2.3. The change in kinetic energy of the creates 250 joules. Okay. Now we know change in kinetic energy. Do you remember work net equals what we said? Work net equals work net is equal to delta EK. Now you know this. It means you know work net, total work. Let's write nice. So work net is equal to 250 joules. But what we know, okay, it's going down. So negative positive is coming. We're going to just show you. So this work net we know. They said change in kinetic, but work energy theorem. Because of work energy theorem, now we know net work done. So let's continue with our answer. What they ask you now, use the work energy theorem, all right, to calculate delta X. Okay, we are going to calculate using work energy theorem. This is our formula first. Work net is equal to delta EK. First step, writing formula and getting your first mark. And work done by tension force plus work done by friction force plus work done by FG parallel. So gravitational force parallel. And then work done by tension force times delta x times cos angle. And then friction force times delta x times cos angle. We are going to write 0 or 180 for each because parallel or opposite. And then mg. So this is our mg times sine alpha is equal to fg parallel. Fg parallel is equal to fg times sine alpha. Alpha is 30, as you see this one. So fg is equal to m times g and sine alpha. You see that one here. This is fg parallel. Fg parallel times delta x. Let's write g times delta x times cos alpha. So these angles we are going to write now. So if tension force we know 300, but check this one. It is negative. All right, because slowing down, it's going down, sliding down, and then changing direction. Kinetic energy changes, slide down, drop. Yes. So it is negative. Please remember that. Because slowing down slowly, slowing down because of that is negative 450. All right. So, and tension force 300. Delta x, we don't know. We are going to calculate. And cos 180. Why 180? Because direction of motion this way. And your tension force, another. So tension force is here. Direction of force, the angle is 180. I think it's clear. And for friction force is 50. Delta x is here. We don't know. We are going to calculate cos 180 again because friction force this way and direction of motion that way. So just like tension force, friction force, and the direction of motion this way. So it is 180 degrees. This is also 180. 180 degrees, 180 degrees. And when you come to alpha, it is 30 degrees, we know already. And this is cos 0 because direction of motion, FG parallel and direction of motion, as you see, same direction. If we have same direction, we know cos 0. And it is negative. Hope you could remember that. And then negative 300 because cos 180 is equal to -1. Cos 180 is equal to -1. So negative 300, negative 50 plus 245. When you calculate this all, you're getting 245 and times delta x. So just you taking delta x from all and just writing here. And then you can calculate delta x 4,29 meters. All right, this is our answer for question 2.3. We almost done. Let's continue with next question 2.4. Let's see what they ask. Calculate the coefficient of kinetic friction on the, okay, we are looking, but now we are going to use friction force. Friction force is 50. Friction force is equal to coefficient number times normal force. So we are using parallel force for gravitational force. Just we are using parallel one now. So we have FG this way, parallel one we did use, but now perpendicular, sorry, now perpendicular, FG perpendicular. So normal force this way. So what we know, friction force, Fk, or you can use small f, it's fine. Friction force is equal to coefficient number times normal force. We know that. And normal force for this system is equal to coefficient number times normal force is equal to Fg perpendicular. And what we know about Fg perpendicular is equal to m times g times cos alpha. Do you remember? It was for parallel one was Fg parallel, it was sine m times g times sine alpha. Now cos alpha. So we are using that here, mg cos alpha. And friction force we know already. Normal force is equal to Fg perpendicular. Fg perpendicular is equal to m times g cos alpha. And then Fg is 50. M is 50 kgs. Is it given? Yes. M is equal to 50 kg. G is equal to 9.8 cos 30. We are using. And you can calculate coefficient number. This is 4 marks. This topic coming from mechanics. This formula from coming from mechanics. And then, yes, 2.4, done. Another question, another day, done. Let's finalize today. See you next lesson. For our lessons, please remember, try first. And then you can get correct answers and you can mark your answers. So this is very important. Please don't forget something. You know what? Not forgetting. Maybe we can highlight it. It's here. Just remember that. See you next lesson. Have a nice day.